So yes, we did the replica of the Bisky, and what we would like to do is to send one to you and maybe to Don, so he can appreciate the quality of this piece of hard work. So it's a design done by folks of ASIMOF, Antonio, Mauro, Roberto, myself.
Even the handling fixture looks very authentic.
Yes, we were meticulous to make everything authentic as much as possible, close to the real one. We are working in order to get it very close to the real one, including the software.
Is it machined? Is it made out of metal?
Yes, partially is made of. Ciao, Sam. It's made of metal. Yes, and on the back is a plastic ABS 3D printing, but the front is metal.
Okay.
And
Darius 77 and now. Yep.
And of course the software is the one close to the original, because we are emulating exactly the assembly at the same frequency. So it's a 11.7 microsecond each instruction, and so we can have a very reliable behavior of the machine. That's a goal. Okay, thank you, Antonio, for a short overview.
Hello, everyone.
So just a recap, just to see if we have all the folks connected. I could see Don Eyles is online. Thank you very much. I can see Ken Goodwin.
Roger that, flight.
Thank you, Ken. There is Bruce McCoy. Is Bruce connected?
Yes.
Yes, of course. He was the first to connect. Yes. Larry.
Yeah.
Larry
here.
is here. It's
Yes,
on
Larry.
the other page. Sam is here, and Peter.
Okay.
Here.
Ciao, Peter.
Hello.
Ciao.
Peter Volante. Guess his origins.
Bene.
Velante.
Fantastic.
Peter Velante.
Yes.
Then we also have of course, our queen tonight is Rosemary. Thank you very much, Rosemary. And
It's a pleasure.
Rosemary, she is the daughter of one of the 3 astronauts who were part of the Apollo 14 mission, who just landed on the moon yesterday, 50 years ago.
I know.
And the success story of this landing is also, we need to give a big thanks to those guys that are with us tonight, Don, Ken, Bruce, Larry, Peter, and Sam, because they did an outstanding job achieving on the goal to rewrite, let's say, or create a workaround on the Apollo guidance computer, or better, the lunar guidance computer of the lunar module, because there was an issue at the time during the landing of the lunar module. They found out that there was a problem with the button. Unfortunately, that was the abort button. There was some false contacts, and this created the issue. So, guys, before starting officially, I would like, obviously, to say thank you very much to our friends at the ASIMOF team and This is a meeting under the title Un venerdì fra le stelle. It's a brand of conferences that we started 3 years ago together with Stefano Savina. They were live events on the theater, and now we are doing them, of course, on the video. But that's the beauty of this pandemic situation. We can run an incredible event involving people all around the world. We have this great collaboration of a lot of friends, starting from the Gruppo Astrofotografico Varese, Antonio, the Observatory of Suno in Piemonte, APAN, Osservatorio Galileo Galilei, and they are hosting us tonight. We have, so thank you, Corrado. We have our group of the Observatory in Tuscany, AAAV, Alberto Villa. We have also Fabrizio Bernardini, who is our friend from BIS Italy. We have the Observatory of Lignan in Valle d'Aosta with Andrea. Thank you. We have Astrofarm from Luca Fornaciari and the GAT from Varese, Cesare Guaita. So those are our friends. We are collaborating with them, organizing those incredible events. And I would like, before starting, just to check if we have Lucas Biglietti from Swiss Apollo. Is Lucas online?
Sì, ciao Dario.
Ciao.
Buonasera a tutti, va bene?
Ciao Lucas, thank you very much. And thank you to Lucas. We had the pleasure to have Rosemary Rusa tonight. Is also President Mario Clerici connected? Oh, so? It looks like it's not yet. Anyway, let me starting this video from Clerici. I am going to share the first video for tonight so we can start the event, and then I will tell you why. So here it is.
Hi, here we are in the Vineta Park, north of Milan, near the Lake of Como. Behind me is the moon tree. We thank to Miss Rosemary, who gave us this tree. It's here to remember a man, but to remember also a whole generation who spent themselves for the whole mankind.
So, grazie mille, Rosemary. So, we are waiting your return back to Parco Pineta for your moon tree.
Oh, it looks beautiful.
Okay, so the story goes back to 10 years ago when we had the pleasure to have Rosemary in Italy, and she brought us, and this is the only moon tree we have in Italy, this fantastic piece of remembering of his father. So, Rosemary, would you like to tell us why you started this adventure about bringing the moon trees around the world, remembering your father?
Yes, it's a beautiful story, and I so enjoyed being in Italy 10 years ago, celebrating the 40th anniversary of Apollo 14. So I'm so happy to be here with y'all tonight, celebrating the 50th anniversary of Apollo 14. And so my father grew up going out into the woods. He hunted. He liked to walk, and he enjoyed nature. And so prior to him joining the Air Force, he was a smoke jumper with the U.S. Forest Service. And so after he joined the Air Force and became a fighter pilot and then a fighter test pilot, and then was selected to NASA in 1966, he was then chosen to fly to the moon. And so on Apollo 14, he was approached by the Forest Service to take a variety of tree seeds with them. The astronauts at the time were allowed to take some private articles with them. And so he wound up taking a canister with 5 different varieties, one of them being a loblolly pine. The others were the American sycamore, the sweet gum, the Douglas fir, and the redwood. So they circled the moon with him, and they came back and they germinated the seeds. They weren't sure if they would germinate. They weren't sure if the effects of deep space or radiation or something like that would affect the growth of the trees. So they did an experiment here, actually not too far from me, with the loblolly pines. And so they wound up growing normally. And so out of those seeds that he took, which were approximately 450 seeds, there are less than 100 of those original moon trees left. So I decided we just could not stop. We just couldn't let these trees die. So I picked up with the 2nd generation trees and have been planting them all over the world to show and promote conservation, to unite and to inspire. And so we wound up giving Italy loblolly pine from an original moon tree, and it looks like it's growing very well. And I think it's just such a beautiful, beautiful thing that he did, because these trees will soon be one of the few things living from the Apollo era. And so it was just really awesome. And I see the poster up there. It's such a beautiful remembrance. And so we would like to inspire the next generation, and we want the trees to do very well.
Yes, great. Thank you very much, Rosemary. This is true. We have something who is living today in most of the countries around the world, just to remember this incredible, fantastic, unique adventure, which is the story of the Apollo missions. We hope to be able to get back to the moon soon, but at the moment, we just did it 6 times 50 years ago with 12 men walking on another, let's say, body in the universe. That's a unique experience that we are still remembering, but you're right. So thanks to you and your courage to bring it around the world. Can you tell us how big are the original 100 trees today? How tall they are?
I'm sorry, I missed your question.
How big are the original trees?
They're very big. They're very mature now. And the other trees have either died of disease, or maybe somebody didn't know, they've chopped them down, or they've been hit by fire or flood or something like that. But the original moon trees are fairly large, yes. And I just want to add to that these trees really do represent a unique part of Apollo, because they represent the successes and the failures and the sacrifices. So it's just a beautiful thing, though, to have these trees living. And I always say they're trying to reach back to the moon again. So it looks like it's your tree there in Italy is growing really strong. And I just want to add too that I know you've got a lot of speakers tonight, but while I have this moment, my father was sitting on top of the rocket, of course, the large Saturn V rocket. And he used to say he got the fame and the glory, but he knew it was a cast of thousands that got him there. And he was always very humble about that and how many hands it took to achieve this mission. And he appreciated every single person that added to the Apollo program and to their success of their mission.
Yes, thank you. That's a very, very unique thoughts. Wow, that's remembering to me the incredible moments that I had the pleasure to spend with another dear friend who passed away 1 year ago, Alfred Worden, and he was also another unique man, and I'm still remembering great days that we spent together. And those guys who went to the moon, they are all fantastic. They are all bringing back something inspirational for the next generations. That's really the message. We were able to go to the moon, and we discover how small we are as a human being on this blue pale dot in the universe, and they brought back this great message about what we can do when we are working together, we're working in teams, and we are creating something based on some dreams. And this is also the reason why with my friends, we are still trying to keep alive this dream and to make sure everybody, especially the new generations, they understand the importance of the achievement that a group of more than 500,000 people did in the 60s to make sure that we could achieve something impossible. And that's very unique. Okay.
They really truly did it for all mankind.
Yes, absolutely. Absolutely. We have tonight also a friend of us, which is Paolo Mignussi, who was one of close friends of Ed Mitchell. And Paolo, would you like to remind us your project about remembering Ed shortly? If you're okay.
Buonasera a tutti. Hello everyone. Cosa posso dire su Ed? Beh, c'è stata un'assidua conversazione negli anni con lui. Tutto
Paolo,
nacque...
can you do it in English?
Ok.
Thank you.
No, pensavo che ci fosse qualcuno che poi traduceva, quindi anche
No,
perché magari...
Okay. Vai di English.
Ci provo, perché il mio inglese non è...
No, you have just to tell us the projects you have in mind.
Okay. Well, I would like to collect some video from Eyles, also Rosemary, and everyone who met at Mitchell, and had something to talk about him, about a special view of the war, special view of the mission of the Apollo 14. So I'm trying to editing a video and a little tribute to him, and for a special friend of mine. This is the little project. So I will write an email to. I try to do that and make some, I would say, some special transition here in my place. So it's a little surprise. So I don't want to talk anymore. That's
okay.
Okay.
Yeah. Thank you, Paolo. So we are also working on creating something special to remember Ed. because this was one of another close friend of us, especially of Paolo. So thank you, Paolo, for this initiative.
Welcome.
So I think we are ready to move to the next step, and we want to learn about the youngster from MIT Instrumentational Laboratories about what happened 50 years ago, yesterday, while Ed and the captain, Shepard, they were supposed to land on the moon. They were orbiting around the moon on Artemis, and something happened. Don, would you like to start, please?
Well, let me unmute here. It's a great pleasure to be with you all today. As I said in my letter, I'm looking forward to today as a time for me to do some listening. God knows I've done enough talking about Apollo 14, and we have, you know, a number of other people who have their own aspect of it to talk about. I would suggest that we go first to Ken Goodwin, who was in Houston when this was happening, and perhaps from him to Bruce McCoy, who heard about it in the room where we monitored missions and brought the story to me. And then I'll say a few words, and then maybe we can go on to Peter and Larry and Sam Drake. Is Sam on?
Yes.
Yes. And maybe they can talk about you know, what we went through in Cambridge to have enough faith in the procedure to send it to Houston.
Yes, great. So it's up to you guys. You're free to step in and tell us the story. So,
Ken, you want to go ahead?
Yeah, sure. Dario, do you have my the presentation I sent you?
yes, let me just find
While
out.
you're doing that, let me tell the story as to how I thought I was going to be a hero on this one. The issue came up during the mission, and I'll explain that in a few minutes here, that there was a problem with the button, and I told NASA not to worry, that we had it already figured out. So the first chart here was to give you an idea that there were a lot of buttons and switches in the Apollo vehicles, and this is a picture of the command module main display panel that the three astronauts would sit in front of. And you can see there's a plethora of switches there. So the next slide there, Dario. So my response to NASA almost immediately was, hey guys, don't worry, we've got it figured out. Turns out I was totally confused as usual. Apollo 15 was going to be the last revision of the software. NASA knew the Apollo missions were coming to an end, and they told MIT that after Apollo 15, there would be no further software releases, although Don figured out ways of getting around that, which is another story. But one thing we had seen were a number of switches that had failed. So we had worked on I think it was probably an erasable procedure, Don, and it may have only been the command module, but we thought we had a built-in, I thought we had a built-in program to take care of it. Turns out I had been working on Apollo 15 and had forgotten that we were flying Apollo 14 at the time. So had the issue occurred later in the missions, we might have already had the solution. So I missed out on being a hero. How did the event manifest itself at Mission Control? I think, as I remember it, there were only two lights in mission control that gave the flight controllers an indication of the problem. There was a light on the guidance officers panel, and there was a light for the abort button on Jack Garman's console, who was the support. And the light flickered on, and none of us saw it, but somebody caught it. And of course, the first question was it a true indication of what was happening? So the people in mission control asked the people on the first floor of mission control, the real-time computer complex, was that a command that they had issued to the display panels on the third floor? And the computer guys looked at their output and said, yeah, that was a valid command. Most of us thought it might have been a glitch at the time. So NASA went further back and asked the people at the Goddard Space Flight Center who had the raw telemetry data to look at the actual telemetry data from the vehicle to verify that it was a true indication of what was on board. And sure enough, the people at the Manned Spaceflight Network verified that the command had come from the vehicle. And so we were off to the races, trying to see how to get around the problem. But it was.
Yeah, I remember that we had put in a system to lock out things of this sort, but I didn't remember that we started doing it until after Apollo 14. I didn't realize that you were already doing that in the command module.
Yeah, it was. I had been testing Apollo 15 software rather extensively, so it was rather current in my meager mind, but I was off by a flight. Okay, what else did I have here? Oh, give me the next chart there, Dario. I think that. Oh, so let me skip to the end of the story for me, because there are other people. The rest of the issue was Don went off and worked it with the people up in Cambridge. He sent the first revision down, and the word came back from the simulator people in Houston that it didn't work. By then, Don knew it wasn't going to work, so he came out with the second revision. So it was a little discouraging for us to hear that the first one didn't work, but Don knew what the problem was as soon as he set it off, I suspect. He knows better than I, obviously. But it was, we were under extreme time pressure to see if it could be figured out. We did lose a revolution. We ended up going an extra revolution around the moon to accommodate the fix, the workaround. That caused a minor hiccup into the mission planning, but the guys in Houston are pretty flexible, so they worked through it. And the rest of the story can be explained by the other speakers here. It hit me just recently with this event that I owed a thank you to Don over this, and that was I had been working on an experiment for Apollo 14 that was a precursor to Apollo 17 to use the inertial measurements unit on board the vehicle to measure the lunar gravity. And
okay, so they were the famous MASCON measurements?
Well, that's what got their interest in gravity, obviously. There was an experiment on board Apollo 17 that was worked by the laboratory to actually measure gravity extremely accurately, and it was an instrument that was placed on the back of the rover. And but one thing that came out after Apollo 11, NASA put forth two desires. One was we needed to figure out where we landed exactly. Apollo 11, we really didn't know where we landed. So pinpoint accuracy was one requirement they needed. And the other one was they wanted to extract as much scientific data out of the remaining Apollo flights as possible. And so they, you know, hey, have you guys got any ideas? And the one that was obvious to us was, hey, why not measure gravity while you're on the lunar surface? So me and a number of other people, Ralph Reagan was the real pusher behind this, by the way, worked on an experiment to measure gravity at the Apollo 14 landing site. And there's a picture there of the paper that we wrote describing the results of the experiment. But if we hadn't landed that night, all my work to design this experiment would have gone right out the window. So in fine Italian, Don, grazie.
Well, I wasn't so much aware of that either. Couldn't it have gone on the next mission?
It actually was run on all the remaining missions.
Okay.
But this was the this was the critical event. I asked myself, why me as one of the really junior people? Why was I on? Why had I been assigned the landing? That usually wasn't the case. I usually got assigned the sleep cycles. But since this experiment was going to be conducted shortly after they landed, they gave me the honor of being there for the landing.
Ken, everybody's familiar with the main room at Mission Control, but of course there are these back rooms. And I don't think I've ever totally understood how all of that fit together. There was a back room that you would have been in, and I suppose Russ Larson, Jack Garman, is that right? And what was the structure of the back rooms, so to speak?
Essentially, every person that you saw on television, in what we call the MOCR, Mission Operations Control Room, every person that you saw on console had a room of experts backing him up. So what was shown on TV was only the tip of the support iceberg. And so Jack Garman's position, and we were afforded the opportunity to have both a lunar module expert from the lab and a command module expert from the lab to staff the consoles in the back room. And they were connected directly to the person in the front room, the MOCR, that they supported. So it was, there was a lot of talent behind the guys on television. And as I indicated in the presentation there was a whole floor of computer equipment on the first floor of Building 30, the Mission Control Center. So the first floor was all computer equipment. The second and third floors were the alternating control rooms. I think that started with Gemini when they had two vehicles going at the same time. But they would alternate between those rooms. The one that was used for Apollo 11 was just recently refurbished, all funded by donations. And for the Apollo 11 50th anniversary, they had a coming out party for this extremely accurate reproduction. It wasn't a reproduction, restoration. They restored the Mission Control Room in Building 30, and it's a national landmark. So, but they did a fine job. However, for the MIT guys, the MIT loop didn't make it onto the consoles. I had a beef with them on that one. The laboratory had a rather precious position of actually having a direct connection into Mission Control, in addition to the support people that were in the back rooms.
Was that from Doc Draper sitting in the VIP room, or how did that connection work?
No, it was a working connection. That's why the scammer room was there.
Okay.
I think we were the only contractor that had direct access into Mission Control.
Who did we talk directly to?
Our loop was connected into the engineering support in Building 45, Jack Garman's console, and the Guidance Officers Council, Steve Bales, for instance, on
Okay.
Apollo 11.
Very interesting.
And you know, the rest of the guys could tap into that too. There are probably a few times where the flight director talked to the lab directly.
Mm-hmm.
In the meantime, I'm showing you guys, Larry, Sam, Peter, Bruce, Don. Ken is not here on this on the right side because he was in Houston. And on the left, there is the famous picture with the big boss, Dr. Draper, showing the team from Cambridge, Massachusetts.
I can assure you, Doc was never viewed as a boss.
It's true.
Great.
Well, would you like to have a go at it now, Don?
Yes, I was just going to say, let's go to Bruce.
Okay. Okay. First, I want to say that in Cambridge, we had a lot of facilities, not only for development, but also testing and validation. We had a hybrid lab there with had an actual guidance computer in it and a mock-up cockpit, much like the one that's behind Don there. And the analog computers, which would simulate all the mechanical and engines and the interfaces, so that the computer, guidance computer, would actually see a real-looking data. We didn't have an inertia system because it would be live, but we had all the interfaces there, so the computer itself could actually look at an abort button that was in the cockpit. So we had actually a good replication of what was in the spacecraft. And we had done numerous testing. The astronauts had been up. Don's probably spent, and Peter and Larry probably spent a lot of time in the mock-up cockpit going over what the guidance system did and sort of training the astronauts before they actually had the training simulators in Houston and in Florida. There we have on the left side the actual cockpit mock-up of the lunar module. We also had one for the command module. And on the right side, you can see all the analog and digital computers there that I don't think I see the rack where the actual LGC was, or the guidance computer was.
I think it's the rack that has the disky on it in the upper right picture.
Oh, you could be right. Yes, yes. Okay, that's it. Anyway, we had direct control of the computer. We could put faults in and see how during different parts of the mission, I think, a lot of what if testing during development. So we were pretty familiar with setting up a simulation and a case for different situations that may happen. And we were ready in our mission support room, called a scammer room, during the missions. And this was also active during different exercises that Houston did prior to the mission, where the astronauts were actually in a training simulator, and we were monitoring that as well. So we're pretty familiar with the overall mission operations, the timelines, and things like that. So when we got, I think Peter and I were in the mission support room at the time, the scammer room. I think it was sometime early in the morning or so, and that's when we got the call. And we heard we had a voice transmission from the captain to the astronaut, so we could monitor what was going on. So we heard the transmissions back and forth, and then we got the call to do a specific request to see if we could figure out how to get around that button. Peter and I had a quick conversation that I recall about what we should do, and we knew that Don Eyles was the one that did all the programming, and he would be the one that would have to figure out what to do. It would take the rest of us weeks to do it. And so I went down and I didn't wake Don up. He was working late that night, I think. And so we got him started on it. At the same time, Peter and Larry Berman, I think, came in later that day. But I wanted them to start to think about, we had run different simulations, of course, for aborts, but I wanted to make sure that if the abort button did show a short circuit there during the landing, at least we'd be confident that we could get back into lunar orbit for a rendezvous. So they were kind of looking at that sort of thing. And then Don came back a little bit later, I don't know, 20 minutes, half hour later, and he said, I think I got it solved. I don't recall the exact details. Don knows probably more about that than I do. But then Sam Drake came in and we said, Sam, we got to have this tested out. So pretty much the team was pretty much oriented to get started as soon as Don came up with some ideas about what to do it. And then from then on, it was just going and testing it out and verifying it. And I guess I let Peter give his 2 cents for how he saw it going. Unless you have a question you want to ask me first.
Okay, I can tell my story very briefly.
Go ahead.
Okay, well, I'll briefly tell my story, which largely consisted of me sitting and watching Don Eyles figure out how this had to be done so that the landing could proceed. But the thing I remember is that Sam Drake and I, once Don had procedure figured out and written down, we took it up to the hybrid simulator. And I wanted to mention in passing that that hybrid simulator that you showed on one of your slides was largely the creation of a friend of mine, Tom Fitzgibbon, who did most of the original work putting that together. And it was, of course, a wonderful tool for evaluating the procedures and checking out the software. That's the LMS, I think. That's not the hybrid simulator, but
that's NASA's version.
I think that's at Grumman, I think.
Oh, no,
Yeah,
that's
there it is.
No, it's not Grumman.
This is the hybrid here,
Right.
Yeah.
if I'm not mistaken. And the computer, as I recall, was an SDS.
So why they call it hybrid? Can you tell us why it was called hybrid?
It had real equipment, it had analog computers and digital computers. So it was a hybrid between 3 different kinds of reality.
Wow, yes. So guys, you were working with real hardware stuff, analog computer, and also the digital version of it.
Correct.
Yeah.
Yeah, the digital did a lot of the environmentals, the Earth gravity, all the environmental simulations were done in the digital computer, and all the equipment and the interfaces, like the engine thrust models, the gimbal swinging, all that was done by analog computer. And then we had the real cockpit and the real computer.
Yeah, those analog computers were a mystery to me, but they were sort of fascinating. You'd open up a cabinet and there would be a big array of potentiometers with sort of mechanical linkages, because if you wanted to store a value, it was in the form of the setting of a potentiometer. And I don't know if you can see them in that picture because they're sort of small, but those sort of black rectangles on the lower right picture, those are boards that into which are plugged, a tangle, a spaghetti of wires of different colors. And I gather those are basically how you programmed those machines. But as I say, it was, and that strip recorder that you see in the lower right picture just to the left, which had paper spooling out of it and needles that would squiggle back and forth. That was the way we extracted data from the hybrid computer when we were making runs.
I think some of the reason why they used hybrid or used analog was the fact that you couldn't do it fast enough with the digital computers at that time.
That's correct.
That's true.
So now you wouldn't do that. Now you just simulate everything with digital computers. But at the time, the digital computers weren't quick enough.
Yes, as a matter of fact, if you look at the training simulators down in Houston and in Cape Kennedy, all the simulations were digital. They didn't have any analog or real equipment, didn't have a real guidance computer. Everything was simulated. And they actually had some data that the computer was, the guidance computer was generated, let's say during rendezvous, and because the simulation of 3 different things going on, there was a discrepancy in some of the data, so some of the rendezvous solutions came out kind of wrong. So there was kind of like a little negative training going on there sometimes when the astronauts would see something that was not what they was expecting, is mainly because they were trying to do everything digitally at the time. And as you said before, they just couldn't keep up with it. So there were some errors in their trainings going on, but we didn't have that problem because we have the hybrid.
This picture here that you're showing now, that's at Houston?
No, that's the one at the Cape.
That's at the Cape, yes.
Yeah.
That's not at Grumman. I've been to Grumman. I was to Grumman and went through to the Grumman simulator, and they had a much, this one's also a much fancier simulator than we had, but I think ours worked better. We didn't have real metal on. Ours was built up out of plywood. So that one you saw in the picture on the left side at one point was, in fact, we didn't have the real switches, we didn't have all the real switches on the panels. When I went down to Grumman, they had the real switches that had tritium in them and all that sort of stuff. But ours were just, store-bought switches.
Yeah, there was a similar simulator at Houston too, in addition to the one shown here at the Cape.
Yeah.
And
Yeah, essentially.
Grumman had the most hardware accurate simulator, which was proven in Apollo 11.
I have an interesting story from Grumman. They had some test pilots, and one of the things that they did with their test pilots to make sure that the shock absorbing legs worked well is they hauled the simulator up to the ceiling and dropped it. With the test pilots inside, they were not very fond of that stunt.
Wow, it was a real test, hard test.
Real test.
Yes.
I wanted to say a few words. The story that was just mentioned about the problem with the lunar orbit rendezvous at the simulator down at the Cape Canaveral. And my area of responsibility in the guidance software was the lunar orbit rendezvous in the LEM. And some of you will remember George Sherry. He was the program manager at Draper at an instrumentation lab for the lunar module. And they started having trouble running their rendezvous simulations in the LMS down at the Cape. And what was happening was, as the lunar module approached the command module, it would get closer and closer, and then at some point it would just start drifting away and they wouldn't rendezvous. And the astronauts were a little excited about that. So George went down and he took a look at it, and he came back and he was kind of white as a sheet. But I had been working very hard running. We had an all digital simulator, which was the gold standard for testing the software at the lab. And I knew that the thing worked because we had run that thing 18 ways till Sunday, and we knew everything really that happened. And I said, our simulations work. And then it turned out, after much investigation, that there was a problem in the environment simulation down at the Cape, and something like a matrix transformation that wasn't done quite right. But there was a happy ending to the whole thing.
While we've got that picture on the screen, even though it's a little bit off the subject, why don't I try to explain that view a little bit of the LMS at the Cape. It was a long sort of high room, and there were actually 3 simulators in there. There were 2 command modules, and they were both painted, everything to do with them were painted that brown color. And this picture must have been taken from up near the other command module that's not shown. And everything to do with the limb is in green. And in the operating console, you can see it left with a few people gathered around it, where you would start a simulation where malfunctions could be input by the sadistic trainer that was working the simulation. That was a man named Bob Pearson who had that role there. I got my entree into this device came right after Apollo 12, right after Apollo 11, when we started thinking about the pinpoint landing. And Pete Conrad, who was going to command Apollo 12, invited Alan Klump and I to come down to the Cape. And to discuss the software change that we had made to help with the pinpoint landing. And also, I think he wanted us to see what the landing looked like from his point of view. So on that occasion, we flew a number of landings in this simulator, sometimes with Pete. The cockpit itself, as I say, is in that jumble of boxes in the foreground. That sort of canopy-like affair in the background contained a lunar terrain map in the vicinity of below that, still painted green. Yes, that your cursor is in about the right place now. And there was a bank of lights at one side, and in that dark area, there was a camera that could maneuver in 2 degrees of freedom, and the 3rd degree was provided by the canopy going up and down. And the image from that camera was processed and projected in front of the windows of the limb in some of those box-like shapes. John Young supposedly called this the Great Train Wreck from the way it looked. But it was a rare and very fun and very useful privilege for me to actually use that simulator quite a bit, especially later on when we were checking out erasable memory programs.
And very accurate too.
The visuals were really quite fantastic. And there are some funny stories about that too. I've related them before, but supposedly, for example, when Willy Brandt, the German premier, was there, they put a Volkswagen on the surface so that as they were landing, here was the giant Volkswagen. Ken probably knows a more accurate version of these stories. Somebody else put a dead frog that they found outside the building on it. Charlie Duke was in on it, but John Young, who was flying the simulation, was not. So of course he got very excited as they got lower and saw this object on the surface.
Hey, Don, did you program the line of sight to the landing spot on the lunar module window? Were you the one that programmed?
Yeah, I wrote the code for that. I mean, it was Alan Klump who sort of figured out the equations, shall we say. Right, and I presume that when they tested that out down at the training simulator, I wonder how accurate that was. Do you know anything about verifying the accuracy of that on the simulator? I think it was pretty accurate on the simulator. I still question how accurate it was in real life, what with slosh and other things that were making the spacecraft move around. Could the astronaut really get his eye in that exact right position where the reticles were all lined up? And I'm still uncertain about that, but I've asked Dave Scott that, and who was commander on Apollo 15, and he said, yes, he could, that it was very good. I think those later limbs, I think had some extra baffling that may have helped with the slosh problem. So he may have had it easier. If you actually analyze the redesignations that Pete made on Apollo 12, they don't totally make sense. And one way to explain that is he may have accidentally pushed the switch and pushed the lever in the wrong direction, but it may also be attributable to the to the different things affecting the motion of the eye with respect to the reticles. Right.
And then, how about the height of the astronaut himself? Did you put a variable in there for the height of the astronaut?
No, I don't think we did. I think that was built into the hardware of the limb.
Okay.
When the lines were painted on the window.
Oh,
You know,
I see. I got you. I got you.
There were lines painted on the inner and outer windows, which were, over an inch apart. But for it to really be accurate, you had to line up those scales.
Right.
And the plane defined by those two lines was the plane of I shouldn't say orbital plane, but it was the
right.
The plane ahead of the limb.
Right.
To go back to the Apollo 14 story, while the events that Ken was describing in Houston are going on, I was in my office in Cambridge, maybe 25 steps away from the room where the mission was being monitored. I was contentedly working on, I knew the landing wasn't for another couple of hours. I was contentedly working on a plots program, I believe, a program that took data from the all digital simulation and made nice plots of it. And Bruce came to my office and said, Don, the abort discrete has appeared. And I believe maybe, I don't know if Bruce remembers this in detail, but as I recall it, my first reaction was just to say, well, that's interesting, and go back to what I was doing. And but a very few minutes later, Bruce was back. And at that point, we went around the corner, the next office to mine, but you had to go out in the hallway, and around the corner to get there was a bigger office that was occupied by several people. And I knew that there was a listing of the exact flight program, one of those big books that you've seen the pictures of in that office. And of course, you wanted to have the version that exactly corresponded down to every bit and every address to the one in flight. And so I dug my way to the place where the aborts monitor was and looked at the logic. And what I saw almost immediately was that there was the right way to have turned, there was a switch that turned the monitor on and off. So the monitor could be turned off with that switch, but there was a big but to that, which was that at the moment of ignition, that bit would be set so that the monitor would start functioning. And so even if we set the switch to prevent the monitor from running, in fact, this was how it was already set to the no position, because we didn't want the monitor running until we lit up. But at the moment we lit up, that was going to be set. And that monitor was going to start watching for the discrete from the switch. And the moment when you light the engine was a moment when you, when there's liable to be some vibration, shall we say. And it was pretty clear at this point that the problem was some sort of contamination in the switch. So the problem was that short period of time between ignition and when you could reach in through the diski and reset that bit to explicitly turn the monitor off. So looking at the code, it was apparent, I think almost immediately, that the only way to lock out the monitor during that interval was to tell it that an abort was already in progress by setting the mode register, mod reg. Now, the subtlety of it was that the vital tasks leading up to ignition and immediately after ignition did not depend very much on the setting of that register. That register was what was displayed on the diski in the program segment, those 2 digits, I think, up near the top. But for the most part, the countdown to ignition was being handled by the fairly famous program called Burn Baby, which had its own indication, its own index to tell it what phase was in process. So most of what it did was unaffected. So the first version of the fix of the procedure was to set the mode register to a false value, 71 or 107 octal, and then get past ignition, and then reset the let abort bit, the explicit bit for turning the monitor on and off. And then once that was done, you could restore the mode register to the correct value. One place that the mode register did enter in, however, was the automatic throttling up of the engine, which was supposed to happen 26 seconds after ignition. We started at 10%. And that job would not be, I guess, task would not have been scheduled if the mode register was not showing 63 for P63. So part of the procedure was that the engine had to be throttled up manually at that 26-second point. So that was the first version of the procedure. And the folks who were with us, Peter and Larry and Sam, commenced to run it on the hybrid. And I think I ran upstairs. I was on the second floor and the cockpit was on the third. And we crashed. And unfortunately, that first version had been sent to Houston. It still scares me to think back that because of the bad experience of having that first version, that they might have been prejudiced against any version that we provided. But once I realized that, and I feel a little stupid for not having realized it immediately beforehand, once we realized that, we added another step to the procedure. And at that point, it was complete. It went to Houston again. It ran successfully in Cambridge and in Houston, and maybe at the Cape too, I'm not sure. And so, in fact, it was read up to the spacecraft. There was something like 64, 65 keystrokes that all had to be right, of course, because you were reaching deep into the computer's memory. And I do remember that the question came back from Jack Garman about when to do the keystrokes that had to happen after ignition. Should the astronauts hurry to put those in before the throttle up? And my answer to that was no. Nobody wants astronauts typing rapidly on the diski. And since the LEM barely maneuvered during the first, I suppose, minute or so of the powered descent, there was no harm in the LEM just holding attitude without the guidance engaged. And then wait until after the manual throttle up, which really did have to happen on time, and then put in the keystrokes to turn off the monitor, correct the mode register, turn on the guidance, and return. I guess that's it. And it was a great feeling and very gratifying to hear the procedure read up to the spacecraft. And of course, we were on tenterhooks listening to as in fact Ed Mitchell keyed it into the computer. As everybody knows, there was a later problem that the landing radar didn't lock on when it should have. And it worried me for some time that there could have been something about the procedure that I still hadn't figured out that it affected the landing radar. But in fact, Walter Tanner, our radar expert, figured out what it was. It was the fact that because of the LEM's attitude, even before ignition, there'd been a strong return from the surface that had made the radar switch itself to a different mode, and cycling the circuit breaker for the radar, which maybe Ken remembers who suggested that, but that solved the problem and they were able to proceed and land successfully.
Hey, Don, I want to ask you a question. I don't recall whether during the 14 landing, if the abort switch ever short circuited. Do you happen to know if it did or didn't?
My understanding is it did not.
Did not. Maybe Ken knows. Does Ken?
Hey, I remember that they did see it trip on the way down.
Oh, really?
Interesting. I wanted to. I wanted to ask Dario if they had used Don's procedures to simulate the abort button going off during the landing.
No, we didn't. We didn't make those simulations yet. But we have the possibility to do those simulations. I think Fabrizio is on the call. Is Fabrizio here?
I saw his name earlier. Fabrizio.
Yes. Oh, yeah, he's
Fabrizio a little while ago.
Yeah, and Fabrizio and his team in Roma from BIS, they have built a fantastic simulator, which is exactly using the same software I'm running. So, Fabrizio, maybe we can try to simulate those.
But that's not very difficult because it's only a bit. So it's enough also on your computer. You can just set one bit and it does the abort sequence. But in your simulation right now, you are not running Luminary, you're running Colossus. And in fact, you don't have the full lights on the disk. And so you have to run first Luminary, and then you can reply to this. Of course, there is also guidance involved. It means you have to simulate the IMU and all the stuff related to the things. What we have done is to simulate the flight control modes of the CSM, all the ones, and the flight control modes of the lunar module, but we are still lagging behind a little bit on the landing sequence. I want to run, Don, I want to run Zerlina on our simulator.
Okay.
I hope we can do that. I will ask you some help probably.
Okay. What Zerlina was about was, you know, after Apollo 11 that had the problem because of 13% of our CPU time being stolen, that whole consideration of our CPU margin became, you know, was a recurring theme. And what Zerlina did, which was a little bit radical and it was never really accepted for the flight ropes, was to allow the guidance cycle for the guidance and navigation to expand when it needed to.
Yes, yes. That's a variable servicer, no?
It would have allowed, yes, and it would have allowed variable guidance period servicer, we called it. That would have allowed things like P66 LPD, which was based on an idea. Hi, Fabrizio, now I see you. P66 LPD, which was an idea of John Young's, which would have made it easy. I say easy, but it would have made it easier to land the limb in a very precise spot. But the missions have been so successful that the crying need for that had not been demonstrated. And the change to adopt the variable guidance period servicer scared some people.
Say hi to Denise, please. Say hi to Denise.
She walked past. I don't know why she didn't stay. Here she is.
Ivana says hi also to Denise.
Ciao Denise.
Ciao, come stai tutti?
Tutto bene, tutti a posto. E voi? Bene.
I want to interrupt, so
no,
let you keep...
speak a little Italian. We'll enjoy it.
No, nice to see you, Denise.
Well, yes.
Just to mention that if you want to know all the secrets about the Zerlina, you need to buy Don's book.
Oh, by all means.
And you get all the details.
And Donald
excuse me, I just wanted to add in here that there were some obviously very, very tense moments in Apollo 14, and that was certainly a critical one, whether they were going to land on the moon or not. But you know, these astronauts were considered the old heads. You know, Alan Shepard was 47. My father was 37. I'm curious to know y'all's age. Here you are writing code. You're solving these problems. I mean, y'all were youngins at the time.
I was 24.
27.
I think I was 27.
I was 29. I was 29.
24.
Amazing, truly amazing what y'all did and accomplished and got them there.
But the good news was, since we were all so young, the parties at Houston were fabulous.
The astronauts could party too.
So do you have any video, Ken, about those party you took with the smartphone?
A quick story was my wife went to work in the astronaut office when she got out of high school and came home and told her father, who also worked at the Space Center, that she got a job. And he asked her where, and she said she was in Building 4. And he said, "You're not working there."
But you know, the person who hasn't talked yet about Apollo 14 is Larry Berman.
Oh, well, actually, my part of the operation was the lunar ascent, from liftoff on the surface up to handover to Peter Volante's rendezvous. But so I was at home and I happened to wake up at 1:30 in the morning. And I thought, well, why don't I call into the lab? So I called in and I said, how are things going? And I think it was Peter I spoke to. And he said, well, maybe you should come in. I didn't expect to go in till about 5:30 in the morning. Peter said, maybe you should come in. So I went in and was told what the problem was. And of course, we then spent time trying to look at the code and figure out what we could do. And the expert in it was Don, and he figured it out, obviously. So several of us ended up going up to the simulator, testing things out. That was kind of really my part.
Yeah, I think the main thing is Don. Of course, Don is smart and he knew exactly what to do, but I think part of it is having somebody else validate or look at it and kind of confirm that Don was not making a mistake.
Look it over and say, yeah, I think that'll work.
Yeah.
Crossing fingers.
Well, testing it also and showing that it did in fact work.
But we were a little frantic there for a little while.
Yeah,
it's a business that business that breeds humility about your ability to make mistakes. You know, the point is being able to, catch the mistakes.
You know, one of the things about the code, we have to remember the limitations of the computer and the fact that we couldn't do the kind of programming that people do now when they've got gigahertz computers and terabyte memories. So we did a lot of things.
Computer like this, Larry.
Strange things to save one machine cycle or save one memory register. And I once did a flow chart of the Ascent program with all its attendant stuff. And I took a bunch of sheets of 11 by 17 paper and taped them together and drew this like 7-foot long flow chart. And it was almost impossible to follow unless you were the one that did it. So Don being able to figure out how everything was connected to everything else was really critical because he knew the code so well.
Hey, Don, I want to ask you something. It seems like in my memory that very initially, before we were thinking of a workaround, we thought maybe Don could write an erasable memory code. We had two different parts of the memory, a fixed memory and an erasable memory. And I think it seemed like you put it away right away, that there's no way we could write some erasable memory to work around the procedure. It has to be more of a keystrokes and faking it out. Did that ever happen? Do you recall that, us even considering a erasable memory program?
I remember considering it, and I think it could have been done that way by creating an erasable memory program and only reaching in with the diskey once to send Burn Baby down that path that did not, in fact, turn on the aborts monitor. But I think I thought that would be more trouble and harder to verify and harder to make work than simply poking the program a few times.
Right. And so it seemed like it was considered, but not very long.
I would,
Yeah.
it's not the path I took, you know.
Right.
It's hard to know how it would have gone the other way.
Right.
And I think, Bruce, that the basis of the Apollo 15 and subsequent was an erasable program. So that's probably where that idea came from.
Oh, it was. I didn't know that.
Well,
okay. Interesting.
I think
I got
we
one
did
quick-
put in an explicit lockout for at least that switch after Apollo 14, which must have been in the Apollo 15 and later code.
I had one question. Where was Alan Klump in there that evening? I sort of remember him being there, but you know, my memory may not be be correct.
Alan was at the lab and he's rueful about it, but it was getting late and he was sleepy, and he lay down on the only sofa in the building, which was in the ladies' room on, I guess, the 3rd floor, and so he slept through part of it. And then at some point he was summoned, or he woke up, and he and Dave Moore set up a all digital simulation to test all of this. And I remember that at about the same point as we lit up for the landing, they came back into the room saying that their all digital test had been successful.
Yeah.
So,
I had memories of him being there, but I wasn't too sure after 50 years whether their memory was correct.
Amen.
So
Well, it just goes to show that in moments of challenge, this is the best computer at all, and teamwork.
Teamwork is important too. Exactly.
Well, all of Apollo was a blend of technology and people, you know, both in the microcosm of the cockpit, where we couldn't have landed accurately on the moon without people on board, to the the greater view that we're talking about, where it was sort of a wonder to me that and a beautiful thing it was not just me and the team that sort of came together to go from just the germ of an idea to a procedure that we felt good about offering to NASA. You know, that was a beautiful thing to me, that team sort of spontaneously, as it seemed to me, came together.
There were 4 computers, no?
I'm sorry?
There were 4 computers. The astronaut and the computers too.
Yes.
Yeah,
depending on how you count it, the LIM had 2 astronauts. And as a matter of fact, it had 2 computers. It had that little TRW machine that would have gotten them out of if they had to abort on Apollo 14, they would have aborted on the AGS, because it would have been harder to select the abort on our computer as a result of the procedure. The procedure would have had to been undone before they could.
okay, if I can ask a question about AGS and the AGC. If I'm not mistaken, the only time they used the AGS during the Apollo missions was on Apollo 13, right?
I don't have a crisp answer for that. I don't know, Ken, maybe. I think it was used in certain ways other times as a double check on the pings.
It seems to me on Apollo 10 they used it, and I can't remember exactly what that point was during Apollo 10.
Well, that was when Cernan came out with the swear word when they switched over to the AGS, and it flipped them 90 degrees instantly.
Oh, that's it.
No, I think, sorry, I think it was used also on Apollo 11, because during the final maneuver before the docking of the lunar module with the CSM, just before returning from the surface, and Neil Armstrong brought the platforming gimbal lock. So he shifted to AGS to complete the docking, to the AGS.
That sounds right.
Yeah, but it never, you know, if you think of its primary purpose as getting the astronauts out of trouble if the computer crapped out on the lunar surface or on the way down, it never had to do that. Thank goodness.
It seems to me that. Go ahead.
Go ahead. I was just gonna say, it's amazing the technology that y'all came up with. I mean, the computers at the time, although were just the most sophisticated. And one reason that Alan Shepard chose Ed Mitchell was because of his computer knowledge at the time. And so he chose my father for his stick and rudder skills, but it really is amazing and fascinating what y'all came up with back in the day.
Do you have personal memories of Al Shepard?
I'm sorry?
Mary, do you have personal memories of the other members of that crew?
I do. I really grew up, you know, as a small astronaut corps. So as a child, my first real memories are in Houston and then going down to the Cape. And so my father, you were showing the simulators earlier, he wanted us to know that there was danger involved in what he was doing, but he was loving what he was doing. And so he let us crawl around all the simulators and really get a feel of what he was accomplishing and what he was working and training on. But I do remember Alan Shepard. I remember the astronauts, and of course got to know them quite well over the years. So
hey, Rosemary, let me ask you a question. As I recall, the Apollo guidance computer was the first digital control system, which meant it was more like a robot, except during the landing and docking where a manual procedure had to take over. And I recall talking to Rusty Schweikert, I think back on Apollo 9, and he was telling me something about how his role has changed from a stick pilot to an engineer. The astronauts had to know a lot more about the systems on the spacecraft and actually flying it like they would in an airplane. Did your father ever talk about that experience of the computer actually flying the spacecraft and he was telling the computer what to do? Did he ever express that experience to you?
Well, I do know he talked about checking the computer with his own manual calculations as well. I mean, they certainly wanted the computers there. They knew they were important. They cross-checked through stars and things like that. But yeah, they were critical, and they needed the computers, of course, to help them along.
Of course, he was in the command module. He was in the command module by himself, flying around the moon.
I do know he talked about that he learned the systems. You know, he that was very, very important to them. That the astronauts were involved. They had a little bit of say, of course, in how they were constructed, right. And so they studied extremely hard to learn all the systems. And of course, with my father as the command module pilot, he knew that inside and out and knew what every single button meant. And of course, they trained for these emergencies. Not, you know, Apollo 13, he said was like flying an airplane and the wing fell off and you're going for the checklist to see what to do. I mean, there were so many unprecedented things that occurred, but they certainly trained to know what every system did. They worked with the contractors to help build it. And at the time, my father was back in boosters. Everyone was trying to get on the lunar module. He said that's where, you know, all the fun was going on. But he and Charlie Duke were in Huntsville working on boosters. But they did learn. They studied. They knew what everything did. But certainly, computers were a new thing at the time, and right. And it's incredible. I'm just really fascinated to hear y'all's input and how you did it, and the code writing and the checking and all those things.
Yeah, the way I tell the story was I was sort of considered, let's say, the computer expert in Houston, and there were 13 major systems in the Apollo program, and those guys knew those 13 systems, even the computer system, better than I did.
Yeah.
Just amazing.
And on Apollo 9, you
Why-
mentioned that my father studied that mission so much that he was very helpful on Earth. He was the Capcom and one of the Capcoms, and he was really instrumental in helping them guide through a very complex mission with the docking and the rendezvous. And so, yeah, he definitely knew his stuff as well, and may have worked with some of y'all, I don't know.
No, they did. Plus, there's another way of looking at it. Since their lives depend on it, they knew it.
Absolutely.
Hey, while I have the microphone here, the people looking at Ed Mitchell there, he got his doctorate in MIT, and I'm pretty sure his thesis advisor was a lab employee. So you might want to look into that aspect of Dr. Mitchell's life.
I tell you what, Alan Shepard certainly relied on Ed and his computer skills, and was a commander that really let the crew do what they did best. And I have to say that there are other missions that talk about their commander, but he was really a good commander in that aspect.
Well, there are these stories told about Shepard, of course, that, you know, he was a bit of a ogre to some people, that he wasn't necessarily that nice to deal with in Houston. You know, my only real encounter with him was at a 2-day, I think, crew training meeting at the Cape. And he was as jolly, happy a person as I ever saw, but of course he had a mission then. So I don't know if you saw any of that sort of behavior in Houston, or, but of course you were a kid, so I would hope you would be nice to a kid.
We did not, but he certainly had that reputation. And when my father first arrived into Houston, he feared Alan Shepard so much that if he saw him going down the hall, he would duck into another hallway.
Oh,
and
really?
here he wound up flying with them on the prime crew. And my father never served on a backup crew. So Alan Shepard certainly, you know, they talk about the rookie crew, but he was impressed. And of course, they were a very professional crew. They were a diverse crew. They didn't hang out and party together, but they were very much precision oriented, and particularly after what happened with Apollo 13, they all felt that heaviness and that sense to get the program back on track. And my father used to say there's no better person that could have done it than Alan Shepard, our first American in space.
There was when I was living in the west side of Houston and driving about 30 miles from where I lived out to the Space Center, every morning Alan Shepard would go past me in his Corvette at about 100 miles an hour.
They like their Corvettes. You know, Chevrolet gave them all a vehicle to drive, and they all picked the Corvette, except for my father, who, like I said, liked nature and liked to hunt. And so he picked a Blazer. I'm sorry, not Ford, the Chevy, but he picked a Blazer. And so he was the only one without a Corvette. But
No,
they
John-
certainly liked all the high speeds.
Yeah, John Young had a Pinto, and there's a long story behind that.
Well, go ahead.
I gave a eulogy at John Young's ceremony here in the city, and I told the story of him showing up in a Pinto when all the other astronauts were driving Corvettes, and his wife talked to me afterwards saying that John didn't think that was necessarily kosher to rent the vet at $1 a month or whatever it was. So he got himself a Pinto.
Oh, I didn't know that. They all felt the need for speed, though.
You bet.
Well, they were all risk takers.
They certainly were risk takers. They, you know, I tell people they weren't daredevils, but they were risk takers. And so, but they knew the calculated risk and they were willing to take it.
Yeah.
And like I said, the people on Earth that, you know, y'all had challenges too, and y'all were certainly men of challenge and late women of challenge as well. But it certainly was a challenging time, and people lived up to it.
By the way, Don, I know you've spoken around a lot about your experience on Apollo 14, and I've talked to a couple of schools here last 2 years ago in 2019, and a lot of the kids were asking me because they understood or tried to understand the intensity going on at the time when we were trying to come up with this workaround solution. And I told them that, and I don't know your experience or what you tell the kids when you were out, Don, but what I told them is we were used to this kind of thing. We did this all the time. There was certainly a time frame on it where we had to make sure we tried to get it accurate and correct, but we were used to working together on solving problems all the time, not just in Cambridge, but also with people like Ken and Jack Garman in Houston, and also the crews. We were constantly working through kinds of problem solving as a group collaboratively. Did you get a lot of questions, Don?
I absolutely agree with what you're saying. You know, our heads were fully in the game because that, as you say, that's what we were doing all the time, debugging the programs, debugging up things, you know, operations and so on.
Yeah.
You know, the interesting part was after Apollo 15, I mean, at a point just before Apollo 15, we released the Luminary 210, I think it was, which flew the last 3 landings. So what did we do then? And I think that's the role that the erasable memory programs that I at least worked on a lot, and some other people did too, that it sort of kept our head in the game during that period when there was really no more code to write. Of course, I was still working on Zerlina because, you know, who knows, maybe somebody would have had some inspiration to do something different that would have required it. But that was the period when I was going to the LMS at the Cape quite a bit, both to check out John Young's idea, the P66 LPD, but also because it was useful to be able to run some of the erasable memory programs on that simulator. But almost fantastical good fortune. I remember I kind of worked out the boondoggle. I'd been lucky enough to be invited to go down as a lab person to the 502 mission. That was the second Saturn V, unmanned, of course. So I'd seen that Saturn V, but by virtue of the work on the erasable memory programs and starting with Apollo 15, I worked out a plan where I would go down to the Cape. You couldn't get into that simulator, of course, leading up to the mission because of the quarantine procedures to prevent anybody getting sick during the mission that were put in place after, what was it, after Charlie Duke was exposed to the measles. I may not have that story totally straight. But as soon as the crew left to go to the moon, there was all the simulator time you wanted for a few days. So I would go down the day before the launch, I would see the launch, and then I could play in the simulator for 2 or 3 days. And I did that for all 3 of those missions, 15, 16, and 17. And I remember the last time I was in there during Apollo 17, it was kind of pure play. There wasn't really anything I was trying to find out at that point. So, you know, I tried out things like, you know, trying to land without the landing radar, and trying to make an even more extreme turn to the left or right while I was above the surface. Of course, you couldn't go backwards in the simulator.
Don, did you ever try to land on Mars?
No, I'm sorry, Dario. It would have been fun for somebody to spray paint the lunar landscape red and call it Mars. Adjust a few parameters for the different gravity and so forth, arbitrarily give the engines a little more thrust and fuel. And who knows what might be possible. Of course, Mars has an atmosphere.
Yeah, absolutely.
So Don, let me ask Don, Peter, and Larry a question about programming. In those days, assembly level language programming, and I think the engineering group would come up. They had the GSOP where they would have basic broad algorithmic equations. But it seemed to me that you guys took that and started programming it without any intermediate high level structure. And then after the fact, you went and documented the coding with flowcharts. Is that correct?
Yeah, I would say so. Somebody designed an automatic flowcharter, I think, that would start with the code and produce the flowcharts. I mean, as I saw it, we outran the requirements document that, we were responding, through our project manager, George Terry, and then Russ Larson to our customer, to NASA. And it didn't go through the stage of a new requirements document. And so the GSOP, yes, it was useful for establishing the language, the coordinating that we were speaking on, in the greater sense, the coordinate systems we were using.
Right.
But one didn't really spend a whole lot of time reading the requirements document, shall we say.
No, it's more algorithm. Go ahead.
No, I was asking if you think the contribution from these two gentlemen, Richard Dick Batten and Ol Lenning, was instrumental for you guys to develop your own routines and programs.
I think they were very influential, but they were, in terms, we were not a very hierarchical bunch at the lab, but these two were at the top of the heap based on the respect we had for them. And as I've said before, as I pictured it, Dick Batten on the left was sort of the heir of Newton and Kepler and Galileo, et cetera, the equations guy. And he was, by the way, if you had to designate a single person who was in charge of the Apollo software, it would be Dick Batten, because all of the strands came together with him. And on the other hand, he wasn't an active manager. I think all our managers sort of realized that the job wasn't going to get done unless they trusted the youngsters, and therefore given the freedom to work as they saw fit. And I think they tried to protect us to some extent from the pressure that might be coming down from Houston. Hal Lanning, on the other hand, did not have an inline management position with respect to Apollo, but he was really the pioneer in so many ways in computer science. In the early 50s, he had created the first compiler, pre-Fortran. And he also did some important guidance system work with missiles. And he designed the Apollo operating system, the system called the Executive, that allowed us to schedule jobs having priorities, and Timeliner that and Waitlist that allowed us to program things to happen at a specific time. It'd be hard to overestimate his role in computer science for those two things alone, and many other things, I think. So, I had during the Apollo years, these guys were so far upstairs that they were a benign influence. And I remember walking a few times around and finding Hal's office down sort of little cubbyhole around behind the computer room to ask something. But, you know, post-Apollo, you know, as we all got older, our ages seemed to equalize. So I played tennis with both these guys quite a lot in, I suppose, the 80s, and got to know them pretty well. I've had Hal's blood on my hands because he tripped up one time on the tennis court and fell down and broke his, you know, cut his head.
Wow. And those two gentlemen, they were already planning a mission around Mars before Apollo era, right?
That's right. I'm invited to give a talk at something called the Flight Software Workshop at Johns Hopkins next week, and I'm calling the talk "Flight Software is from Mars," because the 1958 paper, just 3 months after Sputnik. Sputnik was a small satellite launched by the Russians. 3 months later, the lab was proposing a Mars probe. And part of, and the document, it's like a 30-page paper from 1958. And you can tell it's January 58 by the date that's on one of the figures. That specified all the ingredients except the crew interface that later came into play with Apollo, including an onboard computer to do navigation and guidance and control. And navigation and guidance, maybe not control. So I date flight software to that paper in 1958. It was a Hal Landing paper.
It was even before the Explorer one launch, right?
Yeah, I think so.
Around that time. Wow, that's amazing. Really amazing.
Yeah, I wanted to say something about these two guys. At the time of the Apollo, the digital integrated circuits didn't exist. So Hal Landing and a bunch of other guys came up with the idea of putting together new technology that actually wasn't produced at the time. It was still experimental, and the hardware people had to go out and kind of create this computer from scratch because the technology in the public domain did not exist. And similar way on the algorithms and the navigation and a lot of the guidance and the different schemes, rendezvous scheme, those things did not exist before Apollo. And so putting these concepts together in such a short time really is truly amazing. And I know MIT was selected because of that. Don knows more about that than I do now, but I recall at the time when I was first being joined MIT, the amazing amount of work they had to do at the beginning on their own, essentially, because MIT got a sole source contract to do that. And they had to go out and figure out how to do all this in a really, really short period of time.
Yeah, the person who we should mention here that sort of belongs in the same, you know, a pantheon, if you will, as the two we showed in that picture is Eldon Hall, who was the chief designer of the computer. And Eldon's book, which I'll hold up now, if you can actually see it, it's not that easy to get, but it's on the subject of the hardware. And
if you want, you can get it.
Okay. And the decision to go with integrated circuits, it was an extremely daring decision because they were not regarded as very reliable at that time. And so the work that was done with the manufacturers to be able to have reliable integrated circuits was extremely important for the future and for, you know, everything we depend on these days. Those were pretty primitive integrated circuits. They had a total of 6 transistors on each of them to implement 2 3-input NOR gates. But they were the beginning of something big, and the requirements for the Apollo computer couldn't have been satisfied without that bold decision to use integrated circuits instead of discrete transistors.
As a tribute to the reliability of those circuits, if you remember, in 19 at the 50th anniversary of Apollo 11, we were presented with a resurrected Apollo guidance computer, and it had been rescued from a scrapyard, put back into service, and apparently, as I remember, out of the whole memory, there were 2 flaws in the circuitry from the whole computer. And that's after 50 years of who knows where it was and what it had done to it. So that was really quite a tribute to the reliability of the circuits that Eldon Hall and his crew designed and had built.
The story I like to tell that came out of that exercise, after they had gotten the computer working, they decided to code up a blockchain, you know, a Bitcoin blockchain. And they executed it and came to the conclusion that the Apollo computer would finish the Bitcoin algorithm. It would take twice the life of the universe to complete the algorithm.
Fantastic.
I wanted to mention a couple of other names besides Dick Batten and Hal Lanning and Eldon. I think of 2 people, Norm Sears and Davey Hoag, who were instrumental in really getting the work done. Dave was the program engineer and Norm was pretty much the manager in charge that I could tell, as much as anybody was.
Yeah, I've got a folklore question for the lab people. Was the HAL computer on Kubrick's 2001 movie named after Hal Lanning, or is that just a figment of my imagination?
No, the story I understand is that they use the 3 letters, but if you just go back 1 letter from IBM, you get HAL.
That's right. That's what they did.
Yeah. So I wanted to ask Don and Larry and Peter, after Apollo 15, Don said he was still working on some programming, but essentially the software was pretty much fixed. And I recall an activity, I think Margaret Hamilton asked us to do it, is to go back and see how many really bugs existed in the software. And I think this was time structured programming was coming out. IBM had this new idea about top down, bottom up programming. And there was a lot of concern, not concern, but a lot of interest of how many bugs actually existed in the software. And I think we went through that for about a year, and it seems like I recall there were a few thousand bugs in it. Does anybody recall anything like that?
No.
No. Peter?
Well,
I don't think there were thousands of bugs in the software.
Because NASA had Belcom to do exactly that, and you know they do it every so often, but I never knew of where they ever caught us red-handed.
I don't think there was ever a consequential bug that you could blame the software for. Or
the question was how many bugs in there that existed that weren't that didn't actually happen.
Oh, that not in the final versions, but during development, you mean?
Yeah, after the programming was done and there were no more changes to it, how many bugs exactly not were uncovered during the flights that didn't cause a problem, but how many were inherently in there? You know, John bugs.
I'm a John Norton denier. I don't think John Norton's methodology was to read the code, and he would, as a result of that, he would concentrate on the minutiae, the little things, and you know his critiques that came down to us, we regarded almost as a nuisance, I'm afraid. You know, I think what he did do, and maybe Ken can comment on this, what he did do that was very valuable was to create a a gloss, if you will, a version of the flight software in English that the flight controllers could refer to. And what Bruce said about that exercise uncovering thousands of bugs, I question that. I do not think there were a great many bugs in the flight software, if any.
Okay.
But this also means you should have one bug every 2 or 3 lines of code at the end for thousands of bugs.
You would probably start out that way for sure.
Yeah. Okay, great. Maybe it's close to 11 o'clock, guys. So 2 hours we are talking, and I could stay here listening at you chatting forever. But maybe it is the time to offer the chance to our friends to ask any questions to either Rosemary or to Bruce, Sam, Larry, Don, Ken, whatever. So if anybody would like to ask questions, please feel free to do so. Unmute yourself and ask any question. So we have Claudio.
Yes, thank you. Well, first of all, thank you very much, everybody. It has been really great to talk with the people that lived in the Apollo time. Now, I just would like to make some comments, first of all, about Dick Batten. This is the first time that I have seen a picture of him, but I have been studying his fantastic book about astrodynamics. Now, I would advise any young people, students, wishing to dig more in the transfer from mathematics to astrodynamics. Dick Batten's book is wonderful, not only because it helps you in all regards, but it also because it gives you the historical references, so you feel the progress in the centuries. I'm talking about centuries, in the time of Newton up to now. And in Batten's book, you can really appreciate that. This was the first comment. Then I would have one more comment about Ed Mitchell that has been mentioned many times in this meeting. Well, let me say that I had the privilege of meeting Ed Mitchell and having actually two dinners with him. And the reason is this one. As you probably know, it's a well-known story that on the way back from the moon, he tried to do a thought experiment, so as to say. That is to send a message by his own brain to someone else on Earth that had been alerted, but he didn't know about the message itself. And Ed had not been allowed by NASA to do so. So it was an initiative of Ed in his own, okay? So that was the first attempt, to put it simply, to communicate by the mind only across lunar distances or something like that. And I had a conversation with him about that because both he and I, we have been working in SETI, the Search for Extraterrestrial Intelligence. And so in his view, this experiment that he tried to do was a first experiment on, so as to say, brain SETI, if I may say it that way, that is possibilities of communicating even faster than light across big distances. So I just would like to thank you very much for giving me a chance to mention this. And, you know, you are really bringing me back to the times. There is perhaps one more short comment that I am allowed to make. Going back to the MIT folks, well, among doing wonderful progress in computing and mathematics and all that, they also created a code that was called Maxima, Max Symbolic Analyzer. They were forced to do so because before the flight to the moons, all the equations had been written down by mathematicians in the previous 250 years by hand. And of course, nobody was going to spend, you know, his or her life to check these equations, whether there was a mistake or whatever. So the MIT folks were forced to create this code called Maxima. And practically in a few hours of time, they were checking the whole book about the trajectories to the moon that have been computed 1 century earlier by Charles Delaunay, who was a French mathematician and director of the Paris Meudon Observatory. And of course, they found a mistake in the calculations. So once more, this is a great achievement that the MIT people did. Thank you.
Thank you, Claudio. I don't know if anybody wants to comment about Claudio's.
Well, let me tell you a story about Dick Batten. NASA nominated Dr. Batten for Xavier something. It was a French. It's sort of the Nobel Prize in astronautics. It had a big pile of money behind it, and the recommendation crossed my desk, and I spent many hours putting together the story about the contributions that Dick Batten had made. And then I found out a year later that Dick did not get the award. The people that designed the Boeing 747 tagged him out. I didn't feel so bad after finding out who had beaten this great nomination that we had written.
Well, thank you, Kenneth, for informing me about that. Of course, it is a sad story from my point of view, but it happens, you know. It's not a novelty, really. It happened already, and possibly, unfortunately, it will happen again. Thank you.
Was it the Xavier Bagnaud Award or something? It was a French consortium that had the award.
Oh, the IAEA?
The short of the long story is I have all the work that I did up in the attic.
Kenneth, is that the IAEA, International Academy of Astronautics, that is based in Paris? No.
It might be.
Ah, it might be. Okay. Well, I'll try to get more information. So if we meet once again, possibly I can tell you more. Thank you.
Yeah. Sometimes engineers are first and mathematicians. Sorry.
It's okay. Thank you.
I don't know if anybody wants to comment about the test, the experiment of Ed Mitchell on flight.
I heard Mitchell lecture on it once, and I can't really explain all of his ideas, but you know, we know about the phenomenon of quantum entanglement, and I think his theory was that there was something analogous to that that was very primitive, you know, at the subatomic level, but as objects and then organisms got more complex, that the communication also became more complex. Of course, no one has demonstrated this.
Yeah.
Yeah.
And somebody says, I don't believe there are spooky action at the distance, but this is another story, and I don't think this is the time to go through the quantum mechanics and the history between the battles of Einstein and Niels Bohr. Okay, any other guy is willing to ask any question?
Yeah.
Okay.
Fabrizio Bernardini.
Jerry first, then me. He raised the hand. Go with
guys, there are so many pages, I cannot see you guys. Okay, Jerry, please.
Hello from, well, I was going to say sunny England, but
okay.
I've been a space geek since very, very early. I was 14 years old when Apollo 11 landed on the moon. And it was just shortly after that that I gave my first talk on space. I've been doing this for over 50 years now. Now I do it for a living. I'm covering the 50th anniversary of all of the flights and I've just done Apollo 14 for the British Interplanetary Society last Wednesday. If this event had taken place last week, I would have had a lot of extra material to use. Thank you all for your fantastic reminiscences. It's been an absolute gem listening to you all, and I'd really love to arrange to do something similar for the BIS in the UK. I think the achievement of actually reconstructing the AGS is incredible. Couple of things to mention though, that the bit about HAL and IBM. Now, Arthur always said that HAL was a heuristically programmed algorithmic computer, and that's where HAL came from. The IBM thing is just pure coincidence, even though IBM actually provided some displays that their name was on the displays in the film. Nobody actually realized that at the time. We've talked about the problems that Apollo 14 had with the computer. There was also a problem with the radar before they actually began the landing, the PDI. And that had to be sorted out because mission rules said without the radar, you do not land. And there was always the suspicion that Al, being the gung-ho guy he was, would have just gone ahead anyway. And he was asked about this after the mission, you know, would you have done it anyway? And he just looked the interviewer in the eye and said, you'll never know. So,
if I may comment, I'm of the camp that says he would not have done that. It would have meant outright defiance of the mission rules.
Yeah.
But the radar problem you're talking about was not pre-PDI. The radar problem you're talking about was much later when they had gotten down to an altitude where the radar should have locked onto the surface, but had not yet.
Right.
The thing that had happened that had caused the problem was before PDI, but the problem wasn't actually recognized until it failed to lock on.
Yeah. No, you're quite right. To Rosemary, your father was known as Smokey. Some people may not know that. You just want to explain how that came about?
Well, that actually is kind of a new one to me. I had not heard that until recently because he never smoked cigarettes at all. But I'm guessing that it referred to his days as a smoke jumper when he was in college and putting out forest fires. So I presume that smoking must have come from that term. I just know as a little girl that he loved to buzz. He loved flying in the T-38. And so he would always, we used to say he used to come up over the treetops and the rooftops. I mean, literally feet. We used to laugh. He had grass stains on the bottom of his jet. So I'm not quite sure where the smoky came from, unless it came from his days as a smoke jumper. And going back real quick to Alan Shepard, it is a debate whether he would have just gone ahead and done that. My father personally felt like he would have attempted it, that he would have tried for the moon landing. He had come so far and wanted it so badly that and felt so confident in his abilities that my father called him "Oh, fearless one." So he did answer, "You'll never know," but I've heard my father say he would have attempted the landing.
Hey, Don, I would have guessed it would have been deadly. Isn't the correction, the landing radar brought to the guidance solutions like 80 feet per second?
I I think it may have been, I don't know that number for the velocity correction, you know, the altitude correction could be on the order of 3,000 feet, 1,000 meters for Europeans.
Hi, Ken.
Okay, so Fabrizio, do you have a question?
Yes, very quickly. I have a question for Don and question for Ken. First, a comment that I think that one of the greatest tribute to Hal Lanning is also the fact that the language for the space shuttle was called, the compiler was called HAL's shuttle, actually HAL S. This is important to remember that. And Don, a question for you is at the end of the procedure, I was wondering why I sent you a document actually, so for you to comment later, but why you have to put the throttle back to minimum if the throttle automatic control is an auto? So shouldn't that care that automatically so you don't have to really put the manual throttle in a given position? And then I have a quick question for Ken.
Well, on the throttle, the throttle signal to the engine was a sum of what the computer said and what that lever said at the maximum thrust.
Sorry, now I remember.
The computer had tried to push it down. So yes, that was a necessary step that I forgot to mention a little while ago when we were talking about it. But.
Yeah. Sorry. Now I remember that there was a sum. And that is a pretty unique thing, actually. It's an automatic system that you also can sum up the two signals. I will keep forgetting that. Sorry for the question. And the other for Ken. Ken, are you an amateur radio operator?
Ask again, please.
Are you an amateur radio operator?
Well, don't you notice all the amateur radio equipment here in the background?
That's why I asked 73 to you.
Right. K5RG.
I0QIT. Thank you. That's none. Thank you. It's a pleasure meeting you all.
Thank you, Fabrizio. Anybody else is willing to ask question? Show up.
Yep. I have a question, if I may.
Yes.
Yes. Listening to your stories, it's clear that you had very free rein to decide and organize your work. Is there something in the way Apollo, the whole Apollo project worked, that is impossible to replicate now? I mean, are we too constrained by rules and regulations and standards compliance and management structures to have the freedom that you did? You did incredible things in an incredibly short amount of time. And you were basically a bunch of young people who decided this is the way we're going to do it, and then sought approval from management. At least that's the way I understand it. So is there a lesson in systems management in the Apollo program for current generations, current projects?
Well, let me say one thing is MIT had under contract Computer Sciences Corporation and the Systems Development Corporation. They were on not only as advisors about software development processes, but also they were some of the lead software designers and the operating system especially. So we did hire some background because the academic environment, you know, is pretty much basic. But we did have some contractors. And in fact, I think, Peter, did you not work for SDC?
I did work for SDC, but what we did was really cranked out a lot of code. You know, the SDC did programming on big Air Force systems, the SAGE system, and number of what they called command and control systems. So they had a great deal of experience in software production and testing and so on. But I would say the design, much more came from MIT, really.
Yes, and this was a time before structured programming. I think as Don was saying before, is we had some top level engineering requirements documents, which were more algorithmic and engineering documents. But going from, like that Don said before, going from those documents to code was pretty direct.
It certainly was. There was also the GSOP Chapter 4, which described the interaction between the astronaut and the computer and the spacecraft itself, right? It was huge printout that detailed every phase of the mission in great detail.
But to respond directly to Paulo's question, I do think there's a lesson there for modern system development. And I think that lesson is perhaps, although I have no insight at all into it, is perhaps realized in something like the SpaceX organization and some of the more disruptive technologies that have come to the fore, where perhaps it's their strength to be able to operate more like that than NASA and the companies that are working directly with NASA. But of course, the counter argument is that things are so much more complicated. You know, we had something like 30,000 lines of code, you could say, in the AGC. And I have no idea how much or many lines of code are in the space station core system. And if you add the laptops that proliferate up there, even more. So, you know, whether the sort of, you know, it would be a challenge, I think, to manage a more complex project. You know, we all knew each other. That was a great thing, you know, that there were informal channels of communication that were very important. And, you know, in a bigger workforce, a bigger organization, those might have to be codified and made more rigid. So it is a puzzle how to get the virtues that we were working under, which really were virtues, but how to translate those into the modern environment. And I'm not sure what the answer is to that necessarily.
Let me say something about, we did have a separate independent testing group of which Sam Drake was a part of. And Sam and Don and Peter and Larry worked together during the testing phase. So it wasn't that you turn over to the software and let another group totally handle it, even though they were independent and independent look at it. They worked, as Don said, fairly collaboratively in analyzing problems. Now, one thing I read about, I think a couple of years ago, Don mentioned SpaceX. And one of the things that they claimed is from the Apollo program, and not just MIT, but the Apollo program, is that they decided to reward their testers for the number of problems they diagnosed and found. So they gave an impetus and rewards for finding problems as much as creating solutions, which I thought might be a little bit indicative of let the programmers do what they have, and also have some testing people get a reward to find the problems, to let the designers a little more free rein. That's the way I would read that.
I was going to say something about Charles Stark Draper too. I mean, I was an undergraduate student. I went to MIT in 1961, and I he had a seminar for a so-called freshman seminar, and that's where I met him, and that's how I ended up probably at MIT Instrumentation Lab and Draper, later called Draper Lab. But you know, I didn't realize this at the time, but when I was back at the 50th reunion of Apollo 11, they were talking about the first contract that was let to MIT Instrumentation Lab for the Apollo project. It was written on a single page of paper, and I got so many millions of dollars just to get started. And I asked Draper, you know, how long it was going to take them, and he said, "We'll have it ready before you need it." And he said, "How can you be sure it's going to work?" He said, "I'm willing to fly on it."
I have to break in now and say that I need to bow out. My dinner has arrived. My daughter brought it. So I enjoyed this immensely, and I want to thank you all for participating in this. And I really feel we should maybe even try to do some more at some point. And the other thought that I had is that last year we did a big celebration, well, more than a year ago now, for the 50th anniversary of moon landing, Apollo 11. And I'm thinking that we should start thinking about a 50th anniversary celebration of the final mission, Apollo 17. So that would be roughly a year and a half from now, whatever it is. So I wanted to plant that seed in everybody's mind, and I really think we should do this again. I mean, I just enjoyed it so much. I can't tell you how happy this has made me, seeing you all and thinking about those days. Ciao.
Great.
See you, Peter.
Thank you very much. Peter, you are already invited to be in Italy for the 100th anniversary of the moon landing in
I'll see if I can make
2069. So everybody, you're invited for the 100th anniversary. For the 50th anniversary of Apollo 17, we hope we will be free from this crazy COVID situation by the time. So we hope so. Because thank you, Peter. Thank you very much.
So long, everybody.
Ciao.
Right.
So, guys, it's 15 past 11 here in Italy, but I could stay here all night long, but I do not want to abuse about the courtesy of Rosemary and Dawn and the other friends. Anyway, is there anybody wanted to ask questions? You can also ask questions in Italian, and we will try to translate them if they are not 1 hour long questions. Sometimes. But before moving to questions, I would like to underline the fact that we are in this phase, in these days, seeing a different approach to space exploration done by SpaceX, and they are thinking differently. And as Don mentioned before, they looks like they have a similar mindset of the old days of instrumentation laboratories. And I have the pleasure to be in contact with a friend who is working there. He is a very clever Italian engineer who is living in Florida. And he mentioned several times that they are taking different approaches. The risk is high, but the chance to do things faster is even higher than the risk. So that's a complete different kind of approach than the other institutions and big prime and corporations. Anyway, any other question?
Dario?
Yeah. Luca.
Okay. Yeah, grazie. First, Rosemary, hello. It was a pleasure to have you too.
Thank you, Lucas. It's so great to see you, and I was going to acknowledge you here in a moment.
No. I just wanted to say hello and to say welcome in Italy. You can feel the warmth, you can feel the nice food almost, but next time you have to come back anyway. Yeah.
Yes, go ahead.
And I wanted to say also hello to the guys who helped with the Apollo programs, and big respect for everything what you did for the program. And myself, I'm a pilot flying Airbus, so I know very much what it is, interface man and machine. And so also as an engineer, and it's very important what you did, because what you did, I have now my job as a pilot flying Airbus. So thank you very much, guys.
I just want to say thank you, Lucas, because when we planted the moon tree in Italy, we were actually guests of Swiss Apollo and Lucas, and that's how we went there. So we first planted a American sycamore at the Museum of Transport in Lucerne, and then we went down to Italy with the loblolly pine. But Lucas, that was such a memorable trip, and I know we owe you some more moon trees, and we'll get them there. We've been working with the Swiss Embassy, so we'll be back and we'll be planting more trees. But that's how we got there 10 years ago, and too bad with the 50th we're not there again. But you're always so gracious and love what you're doing with Swiss Apollo. And then I just will also want to say, I know on behalf of my father, as I mentioned before, I mean, he knew it took so many people to get him on that mission. And as we celebrate the Apollo 14 50th, I know he would just thank all of you for all the contributions that you did in such a time when things were happening so rapidly, and y'all really were just rising to the challenge of it. And I don't know how to get back to something like that. I mean, it just seemed all the stars were aligned, no pun intended on that. But I know he would thank each and every one of you for your contributions to Apollo and continuing on today. So thank you. Grazie.
Grazie, grazie, grazie. So we have Paolo wanted to say something, Paolo Mugnosi, or not?
Yes, to Rosemary, if you have some funny and unknown stories about the Apollo 14 mission that your father said it before, he passed away. If you can tell us something funny, okay, if it's possible.
Oh gosh, something funny. You put me on the spot there. It was so interesting because my father was a very private man. He was actually a very sensitive soul, but he couldn't show that in the astronaut corps. He was a family man, and so I used to love watching him give speeches. But early in his speeches, he always talked about the engineering side of it and how many pounds of thrust and what it took and the trajectory and things like that. So it wasn't until later in life, shortly before he passed, that he started talking more emotionally in his speeches and what it felt like for him to be there. I'm trying to think of something that funny or behind the scenes that's not told. He was very guarded because he felt like, you know, Apollo was just so big, it was not to be trivialized in any way, and he always revered it. But he was a simple man that believed in family and what he was doing, and he was doing it for the love of. And I'm trying to, again, think, I don't know if there's anything, you were talking about the ESP experiment. He was not aware that, you know, Ed was doing that. He said he looked over and saw Ed with this flashlight looking at some cards. But, you know, when you see the Apollo capsule, it's fairly small, but he said it was pretty roomy once you got into zero gravity. So I don't know, he was a practical jokester in his own way, but he was not like some of the other astronauts. But I just, he did share some of the emotion with me later on. But he was just a great man and a great daddy, and he raised me to believe in myself, and he taught me how to hunt and fish, and then he actually taught me how to fly. He went and got his instructor license just to teach me. So he shoved me in a cockpit when I was 16, and I got my license when I was 18. And then later he trusted me to run a business. He, you know, a lot of the astronauts, you know, they were talking about, you know, they worked hard and play hard. They always liked their beer. And so he wound up after Apollo, eventually going into the beer business in Mississippi, where I live. But because he was a man of challenge, he kind of got bored with the day-to-day. So he asked me, I was working in Washington, D.C. at the time. And so he asked me to come back. And at the tender age of 25, he put me in charge of a beer distributorship and used to love to call me the beer baroness. And then we eventually sold the business after he passed away, and he's buried up at Arlington National Cemetery and so is my mama now, and we have a moon tree just down from the tomb of the unknown soldier. But it's great to hear all the stories of reminiscing about Apollo 14, and he was just a good man and loved his daughter, and I just miss him so much.
Thank you so much. Thank you.
Yeah. So, Jerry.
Rosemary, is there any chance that you could come to England when circumstances allow, and we'd see about planting a moon tree?
That would be fantastic. We started the Moon Tree Foundation, as mentioned earlier, to make sure that these trees, you know, keep going, and we're keeping the lineage as close as possible. With the loblolly pines, we actually graft them from the original trees that are here in Mississippi, from the seeds. Generally, they're grown from the tree located at Mississippi State University, which is in Starkville, Mississippi, where I was born. At the time that my father was in the Air Force, when my mama got pregnant with me, they were stationed in Pennsylvania, and this is not PC, but she said she didn't want to have a Yankee child, so she came back to Mississippi and had me born in the deep South, where she was from. She went to grade school with Elvis Presley from the 6th to the 8th grade. She was raised in Tupelo. But anyway, in Mississippi, I never know which one's more famous, having a daddy who went to the moon or my mama who went to school with Elvis. But anyway, I would love to come to UK to plant a tree, to bring some seeds. I think they're very special, these moon trees. I really do. Any ceremony, Lucas can tell you, as it was in Italy as well, they're just magical moments, and would love to do it. I have a goal to plant 50 trees during the 50th anniversary, but of course COVID has put a little crimp on that, so I don't know if I'll hit that goal, but we certainly want the whole world to be inspired by these trees, and to really, in this PC world, it's hard to argue with planting a tree, and it just it has so many lessons that go with it, from the past to the future, and they'll live for 75 or more years, and so they're just an awesome thing. And so thank you kindly for the invitation, and let's make it happen.
That would be great. I'd love to do that. I was thinking about where to put it though, and I was thinking perhaps Victoria Gardens next, which is the green that's next to the Houses of Parliament in London, might make it significant.
Rosemary, Rosemary, Jerry, if I can jump in, we could arrange something in November when you come to Paris, Rosemary.
Yes.
We could combine.
Yes, I'm already working on the seeds and the tree, and so we're planning on that in November.
We can discuss together later if you want, Jerry.
And for sure, we would love to put a tree in Rome, and maybe we can ask the help of the Italian Space Agency on behalf of the Italian government to do so, and maybe we can ask Paolo D'Angelo to help us on this. Paolo, what do you think?
Well, let's do it.
Sorry.
Go, Paolo, go.
Good. I think it is very, very important for the Italian Space Agency to have a tree from the moon. Is this point of start new adventure, because the ASI is coinvolta involved in the Artemis program.
Yes, there is a direct link between Italian Space Agency, directly linked with NASA for the Artemis program. other than being part of the European Space Agency. We will work out to have you come to Rome and put a tree for us to remember this big adventure. And if you're planning to come to Europe in November, yes, we think we can do it.
Okay.
I'm ready. I miss traveling, and if anything, COVID has taught us you got to live for the moment, and you never know what the future is going to hold. So let's just keep going and keep inspiring, and we do hope we can get a handle on this and get our shots and take care. I have actually looked. My father had a deep faith, and he actually became a Catholic, and I remember trying to look at planning one at the Vatican, but we know it all takes some connections, and I don't quite have.
We will try. The problem is that the Vatican is so small that I don't know if there is a space for a tree, but we will try.
No.
But Paolo can do it. Paolo is a good friend of the Pope, right,
Yes.
Paolo? Thank you. So we will work with Lucas and Jerry, and we can make it. No problem at all. Any other question? Maybe the last one, because it's lunchtime in Cambridge. I can see John. Nobody has a question, a final question? I can see. Okay.
Dario.
Yes.
I have a question, not mine, but from Gian Maria, because of he is having problems with his microphone. So I will read his question directly. So it is directed to Don Eyles. It's normal nowadays to have an integrated development environment, continuously check the code that the programmer is writing to warn about potential problems ahead of time. And great care is taken in general to ensure that the right compile, deploy, test development cycle be as short as possible. How much time did a typical cycle take while writing code for the AGC? Thank you.
Well, I'm not sure I totally understand the question. How long was the development cycle for the Apollo code? It was 10 years. I mean, it was a single object that got more and more refined as we got more knowledgeable and his missions proceeded. So, you know, we released a new program for each mission through 15. So you could say that we were working to the mission cycle, I suppose. The fact that our code was embodied in a hardwired type of memory called core rope meant that programs had to be released from us. Usually heard 6 weeks before the mission for them to be manufactured in time and installed in the spacecraft. There were a few cases where a single one of the 6 modules was revised without affecting the others. So I don't know. I don't know if I can translate what we did into terms of a software development cycle.
Let me add something to that. Like Don said, we had a release for each flight, and I think they were roughly every 6 months. But the releases were based upon change request, either coming from the engineering side or the astronaut side or NASA side. So they were, we might have a dozen or 2 dozen change requests to come in, and some were quite complicated, but we pretty much cut it off based upon what we could do in that 6-month development cycle. But the Apollo program started with with a different version of the AGC. It was called a Block 1 computer, and then the Block 2 computer. So there was some basic capabilities already in the unmanned flights, and then they started the manned flights with Block 2, as I recall. So the basic software except for the landing and the rendezvous, all the basic software of navigation and steering were in the Block 1, and then they added the other functionality to the later flights as they required them for their mission. If that clears it up anything.
Thank you, Gian Maria. Thanks you all for the information.
Yes, it is a little bit late to talk in details about IDE and software, but anyway, my last question to Don and the other guys is, did you ever get any thanks, warm thanks from the crew of Apollo 14 when they came back home about the fact that you saved their landing? Did they even tell you something like, you are my God, you saved my life, you are the best, whatever that you can share with us?
Well, that would have felt excessive. Oh, you saved our lives. That's not the way an astronaut would put it. There was an awards ceremony, and NASA awarded me a public service award in a ceremony in Houston, and that was the only time I saw that crew after the flight. And it was, you know, we shook hands, but I don't recall it being all that emotional. But it was, well, I shouldn't say that. It was emotional because they did thank us, and which was appreciated. So that's how I would put it.
Okay, thank you. So this is the poster that Alessandro did with you guys. You can see them.
Beautiful.
How nice is that?
Yeah, outstanding, strictly outstanding.
Yes, Alessandro is a real artist, a real guy. He also did this one, and let me see if I can find the third one. Here it is. This is the one with the upgrade version of the Disky with the graphics display instead of the others. With this, I would like to thank you very much, Rosemary, Larry, Sam, Ken, Bruce, Peter, and absolutely Don, who was the guy who helped us to put together this team. And I dare to ask to Don, hey Don, what do you think to have a chat with ASIMOF friends? Would you like to bring anybody else? And he say, yes, let me try to get all my folks. And magically we got this fantastic event. I think we will remember this event for a long time. And also Lucas for bringing Rosemary on this chat. It has been a pleasure, guys, to have you here. And again, yes, we are ready. ASIMOF is here to host you again whenever you want. I will make sure we will get together soon. For the next time, we will move on the other side because I am in contact with the nephew of the chief engineer, Sergei Karalyov. And we want to do another nice event now that we are close to the 60th anniversary of the first man going around the Earth, the 12th of April, 1961, Mr. Sergei Karalyov put a man in orbit around the globe a little bit before the Americans. And we want to celebrate this great achievement. And I am very pleased to say that we will have Andrei Karalyov with us in a few weeks to talk about all the greats that his father was able to achieve for announcing this great achievement. So thank you very much to everybody. Thank you for listening to us tonight. See you soon. We will get back to you. And,
thank you.
Have a nice Sunday.
Thank you, Dario. I just want to say it's so great to see you and just thank you so kindly for today and Godspeed to all of y'all.
Thank you. Good night from Italy.
Thank you. Thank you. Good night to everyone.
Bye all.
Bye from Mississippi.
Spento.
Ciao, ciao, Alessandro, eccolo lì.
Thank you very much.
Shut down the ski.
Alessandro with the stuff, the other one with the dischi, Jerry with astronomy, the lights, Apollo 14. Who else? It's Gianluca with the patch.
Ciao, ciao.
Ciao Gianluca.
Ciao Gianluca.
Ciao, ciao.
Ciao.
Grandi, grandi.
Paolo, prendi questo di dischi.
Hello and goodbye. I just got back in time to say goodbye.
Ciao Peter, goodbye.
Goodbye,
Buonasera,
Peter.
buon appetito.
Thank you so much for doing this. I enjoyed it
Provecho.
immensely.
I don't know who else is. We still have a lot of pages around. If somebody wants to say hello. There is some voices from the moon.
Thank you, buonanotte a tutti.
Ciao, buonanotte. Grazie a tutti. La registrazione è stata fatta. Spero che la regia mi possa confermare che abbiamo la registrazione. The recording is...
Somebody say.
Il regista si è addormentato.
No.
Niente, la rifacciamo domani sera, dai.
No.
Vabbè.
Lo so solo il momento in cui chiudo, perché il momento in cui chiudo me
Ciao a
la
tutti.
consolido.
Thank you very much.
Ciao, ciao. Ciao,
Thank
Timissimo. Ciao.
Ciao,
Ciao a tutti.
Alessandro.
Ciao, buonanotte.
Ciao, good night.
Ciao a tutti. Goodbye.
Ciao, ciao Paolo.
Ciao, Rosemary.
Ciao a tutti. Buonanotte a tutti. Good night to everyone. Ciao, ciao, ciao.
I hope and write some software.
Yeah.
Ciao, Don.
Ciao a tutti.
Go pop a bottle of champagne and look at that lunar surface and yell, to the moon.
We will be to the moon.
To the
Guess
moon.
who will be the first? The Chinese will be the first? Who knows?
Oh, no. Let's get Artemis.
Artemis will be the first. Okay, we will see. Maybe Starship will be the first. Who knows?
Y'all take care.
Yeah.
Take care.
Grazie. Ciao Rosemary.
Ciao a tutti. Io scappo, Dario.
Ciao, good night.
Notte.
Ciao.
Qualcuno ha qualche domanda da fare? Questa volta la potete fare in italiano.
Sì, voglio la traduzione completa in questi giorni.
Sì, le mie tariffe sono ragionevoli.
Ciao Paolo.
Ciao, no, se vi serve ho anch'io fatto una registrazione, quindi se vi serve un piano B in caso di emergenza...
Lo chiedeva giusto Biagio Cimini adesso in chat che non ha potuto partecipare, quindi mi chiedeva se qualcuno aveva registrato, ma immaginavo che qualcuno appunto l'avesse fatto. Quindi.
No, una donazione ASIMOF e si sistema tutto.
Certo, esatto. Sì.
No, faremo questo. Anzi, io direi Paolo, puoi fare... Adesso che hai ascoltato tutto, puoi fare un breve riassunto di quanto
Sì,
in italiano?
Breve.
Veloce.
Praticamente c'era come
Grazie.
tutta una cosa.
Sì.
È presente tipo semovibile.
Sì.
Ecco.
Oh, io
E
scappo,
poi-
io devo partire in ambulanza. Ciao a tutti.
Ciao. Hai bloccato i telefoni.
No, sarebbe bello fare la traduzione di tutto quanto, ma è un'opera epica, non ce la fai.
No, magari la tecnologia ci aiuta una volta che lo mettiamo su YouTube a
Non ce la
abilitare
fai.
i caption.
No, è
È gergo tecnico. Il sottotitolatore già farebbe fatica a capire l'audio originale inglese, poi devi anche tradurlo in italiano, non ti passa più.
No, dico ma mettere sottotitoli in inglese, così magari qualcuno...
Ah, beh, i sottotitoli in inglese forse
Quelli generati automaticamente da YouTube, magari,
capire
o fa fatica a comprenderlo.
quelli generati da YouTube potrebbero anche andare bene, si può provare, male non...
O se no, ragazzi, tanto siamo tutti chiusi in casa ancora, studiatevi l'inglese. Cioè, Paolo Tivissimo vi farà delle lezioni gratuite di inglese.
The pen. The pen.
Is on the
On
table.
the
La
table.
pronuncia, il problema è capire la pronuncia, quello è il problema.
Esatto.
Ah, c'è anche Diego.
Quando parli tu, io ti capisco, quando parla Paolo capisco, ma certi di loro era duro capirli, eh?
Sì.
Poi alcuni argomenti non li sai, perché alcuni argomenti tecnici magari alcuni dettagli non li sai. Per cui se ti perdi mezza frase poi fai fatica a seguirli.
Ma perché parlavano in assembler?
Linguaggio macchina.
Linguaggio assembler, linguaggio macchina.
Dario, te mi hai buttato così all'inizio nella mischia, io non ero pronto, quindi...
Ma me l'hai scritto te, voglio dire te, voglio dire.
No, io non t'ho detto, no.
Hai scritto te.
Sì, vabbè.
E allora ti ho messo dentro.
Dario, io chiudo la trasmissione. Chiudo la registrazione.
Sì, la registrazione.
Sì, chiudi.